Can you guys hear me? Okay, great. I'll wait for a few other people to join and then I'll start the class. Basically, in this particular class, share all the doubts that you have in physics till now. I'll try to cover it up as much as possible. The class particularly will be focused on revision for your upcoming test, and I'll not be taking anything which is not related to your upcoming examination. So no mechanics and all those things which has been written in the schedule. So I'll start doing the revision once everyone join. So only 4 or 5 people are here till now. So can you guys tell me which topic I should start with? Okay, Rushil is saying optics. So few of the things I have already done in optics, but I have given a question. I'll not only do numerical based questions. Reason behind it, that in your exam only numericals will not be asked. In your exams, theory will also be asked. So I will be taking some theory also. Okay, you want to do numerical, right? I'll give you a numerical. Okay, people are not joining. I don't bother. It has been too much of time. Write down a question. It's best on Param. I'll come to magnetism. I'll definitely come to magnetism. Don't worry about it. So let me first solve a few questions from optics and then I'll come to magnetism because these are the two topics you guys have been asking for. So okay, write down the question. The question is a coin is placed in a beaker at depth of 3 centimeter from water surface. So it is not placed. Try to understand. It appears in a beaker at a depth of 3 centimeters. Find the real depth. And mu water is equal to 4 by 3. As soon as you get the answer, you can post it in the chat. What's the answer, guys? Nobody is giving me answer. Okay, one more minute. I'll wait. 7 is a wrong answer, Rochelle. Do it once again. No, that's wrong. Yes, Ria, it's correct answer. 4 centimeter. It is correct, Ria. Your answer was correct. Okay, guys, try to understand. I'm not getting into derivation now. The formula is refractive index of a medium is equal to real depth divided by apparent depth. So refractive medium of water has been given as 4 by 3, that is equal to real depth divided by apparent depth has been given as 3. This and this gone. Real depth is equal to 4 centimeter. Now the question should be why there, I mean, from where does the concept of apparent depth comes from? So that I will explain you. What happens is, suppose I am placing something over here and this is filled with water. So this is water on this side. So whenever a light ray travels from, suppose this is the normal. So suppose my eyes are here. So what will happen? The light ray will travel from here. One second, guys. The light ray will travel from here, and it is going from denser medium to rarer medium. It will diverge or it will go away from the normal. So what happens? Whichever ray reaches my eye, object would be located, for my eye, object would be located in a straight line to the ray which is reaching my eye. So as my eye is here and refracted ray is reaching my eye, hence the object will seem to be or appear to be placed over here. So that is why this is the real depth and this is the apparent depth, and the formula or the equation between or formula is mu of medium is equal to real depth divided by apparent depth. This is how it is. Okay, I'll give you one more question. Now, here only one medium is there. Suppose I keep two mediums, then what happens? So write down a question. The question is, I'll just draw the diagram of the question. So instead of one medium, I have two mediums. This is 3 centimeters and this is 2 centimeters. And mu of this medium, suppose this medium is B, so mu B is equal to 4 by 3. And suppose this medium is A, mu A is equal to 3 by 2. And the object is placed over here at the bottom here. This is the object O. I am asking what will be the vertical shift in the object, in the image of the object. Param, I'll explain how did I get it. After this question, I'll explain. Solve this question. What's the answer, guys? Okay, great, Param. Solve it. Okay, what's the answer? No, 8 by 3 is not the answer, Ushil. Okay, tell me one thing, guys. Should I tell you the derivation of how do we get the formula of mu medium is equal to real depth divided by apparent depth? How many of you want me to do so? Yeah, great. So Param, the answer is 3.5, the apparent depth. I am asking the vertical shift. So vertical shift would be 5 minus 3.5, because see what I'll do is that apparent depth I will be calculating. Apparent depth I'll be calculating from here. So apparent depth is calculated from top. So from top the answer would be 3.5 centimeter. Vertical shift is calculated from the bottom. So vertical shift would be this. If this length is 3.5, vertical shift would be 5 minus 3.5. But how do you do so? So try to understand, guys. The formula over here is, if more than one medium is there, apparent depth is equal to d1 divided by mu1 plus d2 divided by mu2, and likewise. So here d1 is 3, 3 divided by 3 by 2, and d2 is 2, 2 divided by 4 by 3. So how much it comes? It comes out to be 2 plus 3 by 2, which is 1.5. So apparent depth comes out to be 3.5 centimeter. As soon as you get apparent depth, vertical shift would be equal to 5 minus 3.5, which is equal to 1.5 centimeters. Is it okay? Anyone who wants me to derive the formula, I can derive it for you. So let me know. Otherwise, I'll move ahead. Okay, great, Param. So look at here how it is done. There are different methods to derive it, but try to understand. So I'm doing it here. Suppose I have a line like this and I have a object kept over here. So let's draw a normal, and from the normal a ray will go like this. This is I. If this is I, this will also be I. Now a ray goes like this, and this is R, and here R is more than I. And due to this R, what will happen is the object will appear here. So if that is R, this would be R. So this is my apparent depth HA, and this is my real depth HR. So what happens over here is, let's write Snell's law. So by Snell's law, suppose this is mu medium. So Snell's law is mu medium and sine value of angle in that medium, so that it is sine I, and mu air, which is 1 into sine R. So what I get is mu medium is equal to sine R divided by sine I. And now what I need to do is I need to find out value of sine R and sine I in terms of HR and HA. Now guys, try to understand, when I value and R value are very less, so in that particular condition what happens is, suppose, look at here, suppose this is the point and I I have this particular angle. So as if the angle keeps on reducing like this length and this length keep on becoming so hypotenuse. If you keep on reducing the angle, the length of the hypotenuse will start becoming the length of the base. So in that particular condition, if I is very less and R is very less, so in that condition, or what you can do is that directly you can find out value of tan I and tan R even without doing that. So because here sin R and sin I is there, I will be writing here sin I will be equal to tan I and sin R will be equal to tan R. So what happens over here is I write tan R here divided by tan I. Now, so if this length is x, tan r would be x divided by HA, and tan I would be x divided by HR. So if you solve it, it becomes x by HA into HR by x gone. This comes out to be height of or depth of real depth divided by apparent depth, and that is equal to mu of medium. Is it okay? Yes or no? Are you understanding? Yes or no? Okay, no issues. Now, what is the vertical shift, guys? Vertical shift is this. This is the vertical shift. So, vertical shift is, try to understand here. Vertical shift is equal to HR minus HA. So try to understand. I will represent vertical shift in terms of HR. So to do so, I need to reduce HA, or I need to remove HA. So what will I do? I take reciprocal of it. So it becomes HA by HR, and that becomes equal to 1 by mu m. I subtract both from 1. So what I get? HR minus HA divided by HA is equal to 1 minus 1 by mu m. Now this HR minus HA is vertical shift. So vertical shift is equal to, this is HR guys. By mistake I have written this. So HR is, vertical shift is equal to HR 1 by minus 1 by mu m. Is it okay? So if suppose I have to find out vertical shift in this case, so what I can do is that I can calculate vertical shift directly. So vertical shift will be added by all the mediums. So here the vertical shift would be 3 centimeter into 1 divided by mu of medium. So that becomes 2 by 3. So how much it comes? 3 into 1 by 3. This comes out to be 1 plus, here the, this is 2, 1 minus 4 by 3, which becomes 3 by 4. So this comes out to be 2 into 1 by 4. So this is 1 by 2. So this comes out to be 0.5. So vertical shift comes out to be 1.5 centimeters. So that's how you can solve this question. Did you all understand it? Okay, great. Okay, solve another question. Another question I'll give you. Wait for a moment. Okay, write down a question. I'm giving it on the lens. So yes, Param, you can directly add, because what happens, image of this particular image formed by this particular uh, medium would act as an object for this particular medium. So if you derive it, it will come out to be total vertical shift is vertical shift due to both these mediums added. So resultant vertical shift is addition of vertical shifts by all the mediums. It can be derived here. It's same as the other derivation, where I is very small, so I would be equal to r, and you can find it out. Next, this question is, a convex lens of f is equal to point 2, sorry, 0.12 meters produces an image which is 3 times the size of our object. You have to find out value of u. The hint in this question would be that I have not given you whether I am finding out real image or virtual image. So you will have to consider both the cases, one for real image and one for virtual image. No, Param, answer is wrong. Which answer? Rushil, your answer is correct. Param, your answer is wrong. But there would be two answers as I told. The first answer would be for real image, the second answer would be for virtual image. What's the answer, guys? I got only one correct answer. I mean, have you guys got it or should I solve? Let me know. Param, what are you doing? 1 meter is 100 centimeters, not 1000 centimeters. Okay, 1.5 more minutes. Then I'll start solving. So Ria, here your answer is for virtual image or real image. So if you are giving me answer, write down in bracket whether the answer is for real image or virtual image. Yes, Rusil, but I'm asking real or virtual. Okay, great. Okay, fine, guys. Let me solve now. I've got two, three answers now. The rest of the people are not responding. So for real image, in case of convex lens, V would be positive. So in that particular case, first let me find out the magnification. So for magnification, I'm solving here. Magnification is equal to M h height of image divided by height of object is equal to V divided by U. So V by U comes out to be 3 because it has been given images of three images three times. So V by U is equal to 3. Now using this, what I do is that, so try to understand. Let me use the lenses formula. 1 by F is equal to 1 by V minus 1 by U. And let me find out the relationship. V is equal to 3U. Now here what I do is that focal length will always be positive. So I will make it, this is 0.12 meters, so I'll make it centimeter. This is 12 centimeters. 1 by V would be positive, so I'll take 1 by 3U, and this is U will always be negative, so this becomes plus 1U. So this comes out to be 1 by 12 is equal to 4 by 3U. U is equal to 4 into 12 divided by 3, and this comes out to be 16 centimeters for a real image. For a virtual image, the relationship remains same, but the V would be negative. So I write minus 1 by 3U, and this will always be positive. So this comes out to be 1 by F is 1 by 12, and 1 minus 1 by 3 is 2 by 3U. So U will be equal to 12 into 2 divided by 3. So that will be equal to 8 centimeters. 24 divided by 3. So that is how, that is what the answer should be. Now let me give you a question. The question is like this. So write down the question. I'm orating the question, just write it down. It's taking a lot of time for me to write down the question here. So I'll orate the question, you just write it down. Listen to my question carefully. Two convex lenses A and B. It's a convex lens. So there are two convex lenses A and B of focal lengths 30 centimeter and 20 centimeter respectively. What are the focal lengths? Focal lengths are 30 centimeter and 20 centimeter. For A convex lens A, focal length is 30 centimeter. For convex lens B, focal length is 20 centimeter. These two lenses are placed in a contact. The question is calculate the effective focal length and power of the combination. The first question is find out the effective focal length and power of the combination of two convex lenses. This is the first part. I'm again repeating the first part. The first part is calculate the effective focal length and power of the combination of two convex lenses. The second part of the question is if B is a concave lens. The second part of the question is if B is a concave lens rather than a convex lens, the focal length remains same, that is 20 centimeter. I'm just changing the nature of the lens. The nature of the lens was convex in first scenario. Now by changing it, I'm making it a concave lens. So B becomes a concave lens. So again, you have to find the two things: effective focal length of the combination and power of the combination. I'll again read the question for you. Two convex lenses A and B of focal length 30 centimeter and 20 centimeter respectively are placed in a contact. Calculate the effective focal length and power of the combination. Second part is if B becomes a concave lens, then what is the effective focal length and the power? Yes, the unit was centimeter, 30 centimeter and 20 centimeter. What's the answer, guys? So I've got two, three answers. Uh, Roshal's answer is correct, but for only first part. Hia's answer is correct for. Yeah, your answer is not correct for the second part. The first part is correct. Okay. You are giving focal length and okay, fine. You're here. Both your answer is correct. Answers are correct. Roshni, you check your answer. Second part, you check your answer. All of you check your answer. Here your answer is correct. Rushil, you check your answer. Answer is correct, Rushil, in the first part. Okay, one more minute. Others. Good. The first part answer is 8.33 and 12 centimeter. There is no doubt about it. I'm asking the answer for the second part. Okay. Focal length for a combination of lenses is 1 by f1 plus 1 by f2 plus 1 by f3. So first one is 30 centimeter and second one is 20 centimeter. If both are convex, then the focal lengths would be equal. Sorry, positive. Sorry, positive. So focal lengths would not be equal. If they are 30 and 20, there would be positive. So this is 60. This becomes 2 plus 3, 5 divided by 60. That is 1 by 12. So focal length comes out to be 12 centimeter. Now power is defined by 1 by F and F should be in meters. So what I do 1 divided by 12 centimeters, which is 0.12 meter, which is 100 divided by 12. 100 divided by 12 would be 25 divided by 3, which is nothing but 8.33. Now what happens is in second part, um, So let me solve second part here somewhere. So again I will write 1 by f. F1 is 30. F2 becomes, or lens B becomes concave. So the focal length will become negative. So instead of this 20 positive, I'll take 20 negative because nature of the lens has changed. So this becomes 62 minus 3. So minus 1 by 60. So F comes out to be minus 60 centimeters. So power would be 100 divided by minus 60. That would be equal to minus 5 by 3, which is nothing but minus 1.67 D. If you don't write this minus, the examiner will cut all your marks. Why this question has been given? This question has been given to test your knowledge of positive power and negative power of a lens. So if combination is concave, the resultant power would be negative. If combination is convex, if resultant of the combination is convex, the power would be positive. So that's how it is. So this is how it will take a lot of time. That's not required param now. So we'll waste a lot of time. Sometimes in the class after your exam, I'll derive that formula. Don't worry about it. Till now, just remember it. It will kill a lot of time. I'll do this formula in the class. 1 by f is equal to 1 by f1 plus 1 by f2. Next question. I'll take questions based on mirrors also. So this is this is A, this is B. This height is negligible, guys. I'm not giving any height. This height is negligible. Just for the sake of proper interpretation, I have made like this. This height is negligible in nature. So length of this rod is 10 centimeter, and it is lying along the principal axis of concave mirror of focal length. So f of this mirror is also 10 centimeters, and this is 20 centimeter. You have to find out. Image of the rod. One or two more questions, and then we'll move to another topic, magnetism, and then we'll start solving questions from there, or we'll take theory first and then we will start solving questions. Do you guys understand moving coil, galvanometer, and all those things properly? I'm asking, do you guys understand moving coil, galvanometer, conversion of moving coil, galvanometer into ammeter, voltmeter, all those things properly? Focal length is 10. and this is also 10. Yeah, Param, you're right. Others, what's the answer, guys? I'm not getting any answer. Param, it's not 15 centimeter. Just check once, all of you. You guys are giving me value of V. Yes, it's 5 centimeter. Now I'm getting the answer. Now look at here, guys. What we need to do is that we need to find out where image of this end would be formed and where image of this end would be formed. So mirror formula is 1 by V plus 1 by U is equal to 1 by F. Now 1 by V, this is 20 centimeters, so I'm taking negative 1 by 20, and this is how much? Minus 1 by 10. So 1 by V is equal to minus 1 by 10 plus 1 by 20, which is equal to minus 1 by 20. So V is equal to minus 20. It means that image of A would be at the exact location of A. So A dash would be here only. So image of A would be at its position only. Now let me go to image of B. So B minus, this is 20 plus 10 30. So this becomes minus 30, and 1 by F is how much? Minus 1 by 10. So 1 by B is equal to 1 by 10 negative plus 1 by 30, and that is equals to, this is 30. So how many times it goes? It goes minus 3 times plus 1 time, which is equal to minus 2 by 30. So which is nothing but minus 1 by 15. So VB would be equal to minus 15. It means that B dash would be here somewhere, from here 15. So this is at 20 centimeter and this is at 15 centimeter. So distance between them, which is the length of the rod is, length of the image of the rod is 20 minus 15, which is 5 centimeters. So that's how it will come. Okay, next question. An object of height 2 centimeters is placed at a distance 2.5 f from a concave mirror, and you have to find out height hi, where this f is focal length. Answer quickly. Answer. Yes. Rushil, you give me correct answer, but you need to work on the uh, sign rules. I mean, whether it will be positive or negative, that you need to mention in your answer. So sign conventions has to be taken care of. Yeah, so you should write -4/3. The examiner will automatically understand that it's an inverted image. Okay, others answers. 1 more minute. Before I start magnetism, I would like to ask you what topic in magnetism you guys would like me to cover. Okay, DC motor, AC generator. Okay, brightness of the bulb. I don't know whether I'll be able to cover it till 5:15 because I have another class. So whatever I would be able to cover up, I'll cover. I'll try to cover it up. Okay, let me solve this question for you. So here 1 by V plus 1 by U is equal to 1 by F, and 1 by V minus 1 by 2.5 F is equal to minus 1 by F. So I'm writing it 1 by V minus 2 by 5 F, and that is equal to minus 1 by F. So 1 by V is equal to 2 by 5F minus 1 by F, and this comes out to be minus 3 by 5F, or V would be equal to minus 5F by 3. So this is what the answer is. Now what about magnification? Magnification is HI divided by HO, and here it is slightly different from the lenses formula. Here it comes with a negative sign, so V divided by U. So HI would be equal to minus HO V by U, and HO is 2 centimeters. V is minus 5 F by 3 divided by U is minus 5 F by 2. So what happens over here is this and this gone, this 5 and 5 is gone, this F and F is gone, this 2 will go in the numerator. So this will come out to be 4 by 3 F, sorry, 4 by 3 only. So this will come out to be 4 by 3, and I have left a negative, I think. Yes, this negative I have left here. So this will be minus 4 by 3 centimeters. So that's the answer. Now let me move to magnetism, and before that, Let me check what I need to cover it up over here. So as I move into magnetism, first rule that I discuss is inverse square law of magnetism. What is inverse square law of magnetism? That I'll first explain. So uh, suppose I have a magnetic pole. So magnetic pole will either attract or repel another magnetic pole depending on whether the other magnetic pole is of same sign or different sign, or same type or different type. So north pole, if you bring two north poles together, they'll repel each other, and if you bring a north pole and south pole together, they'll attract each other. But what is that force of attraction, or sorry, or repulsion, or how that is calculated? So first thing that we need to remember over here is that ability of any magnetic pole to attract or repel any other magnetic pole is known as magnetic strength, or polar magnetic strength, or pole strength also it is called. And this is represented by a word m, sorry, a letter m. So in magnetism, if you find a letter m, that's related to, m is nothing but pole strength, and m is ability of pole of a magnet to attract or repel another magnetic pole. So that's what I have told you. Now suppose one magnetic pole is here and its PS, pole strength is M1, and second magnetic pole is here, suppose its pole strength is M2, and distance between them is R. So force applied would be proportional to magnetic strength M1 and M2, and it would be anti-proportional to the square of the distance between them. So I can write it as F is proportional to M1 M2 divided by R square. Now what is proportionality constant? Proportionality constant is nothing but mu naught divided by 4 pi, and this M1 M2 divided by R square comes. So you always see whether it is the forces are always, I mean, we have seen it for gravitational force, we have seen Coulomb's law, and now we are looking at this force due to force between two magnetic poles. It can be attractive force, it can be repulsive force, depending on the uh, type of magnetic poles which are kept in vicinity. Now mu naught by 4 pi, mu naught is equal to 4 pi into 10 to the power minus 7, and mu naught by 4 pi hence would be 10 to the power minus 7. So it's very easy to remember this. This is nothing but 10 to the power minus 7. So that's how you calculate. Now, what is magnetic flux, or what is magnetic? So before magnetic flux, let me go to magnetic field. So how, like we saw that in electric force also, whenever two charges are kept in vicinity, there would be some kind of electrical or electric force which is determined by Coulomb's law. would be working between them. It can be a force of attraction or repulsion, depending on the kind of charge it is. If same type of charges are there, repulsion would be there, and for opposite charges, attraction would be there. But how do charges come to know that there is any other charge kept in its vicinity? So there is a concept of electric field line over there, and the interaction of electric field line will determine what kind of force is applied. So in case of same kind of force, same kind of charges, electric field lines overlap with each other, they interact with each other, and their interaction is in such a way that the forces are towards each other. So that is the force of attraction. The repulsive force act because they have two if two same kind of charges have been kept, their field lines will never cross each other. As they'll never cross each other, it shows that the two field lines will repel each other, hence the force of repulsion will work. So anywhere wherever there is a concept of force, here also in magnetic field, in study of magnetism, we will apply the concept of magnetic field. So what is magnetic field? The field lines which are responsible for application of force on any particular pole by different pole. So magnetic force is influenced by magnetic field lines. So what is magnetic flux then? So magnetic flux is nothing but number of field lines passing through any cross sectional number of field lines passing through any cross sectional area. So magnetic flux is given by phi. So magnetic field is, let me write a few things over here, is represented by B and flux is represented by phi. So total number of field lines passing through any area. This is number of field lines passing through given area. And magnetic field is flux per unit area. So per unit area, whatever is the number of field lines passing, that would be magnetic field. So that is how it is. Now you understand that suppose I is defined. So try to understand B is defined like this. So suppose I take gravitational force due to Earth. So I write force on any particular object on Earth as G mass of Earth into mass of the object kept on Earth divided by radius of the earth square. So now I write this as F M O into G. So this G is what? G is the gravitational acceleration or gravitational force, whatever you call, that would be G. Similarly here, F is written as B divided by M another, I mean, suppose there are two poles, and suppose this pole has strength M1 and this pole has a strength M2. So on this pole, if I want to find out the force, it would be force Bm1 into M2. And what is Bm1? If I compare it with this formula, mu naught by 4 pi M1 M2 divided by R square. So Bm1 comes out to be equal to mu naught by 4 pi m1 by r square. So that's how you can correlate this. You can correlate phi, and you can correlate pole strength. So in some question, if you find correlation between phi and pole strength, so you should apply this formula. You should always remember that pole strength Bm1 is equal to mu naught by 4 pi m1 by r square, and Bm1 is also equal to phi divided by a. If you know phi and a, you can find out m1, or if you know m1 and a, you can find out phi. So that is how it is. Now let's get into Orsted experiment. So what did Orsted told? So Orsted told us that any current carrying wire produces magnetic field around it, and it can detect a magnetic needle placed near it. So when Orsted was doing an experiment, there was a bare current carrying conductor and a compass kept near to it. When the current was passing through it, the compass needles were moving. When the current was stopped, the compass needles were not moving. Hence, it was determined that whenever there is a current carrying conductor, so this is if this is current carrying conductor and a current is passing through it, this current carrying conductor will produce magnetic field around it. Now, what kind of magnetic field? So, a straight current carrying conductor produces circular magnetic field around it. So, it would be circular in nature. So, something like this you will find out. So, it is something like this. The second thing he told that intensity of the magnetic field is proportional to magnitude of the current passing through it. So, that's it. Magnetic fields setup acts at right angle to the direction of flow of current. So anywhere, if you will find out the magnetic field direction, it will be right angle to the flow of current. And direction of magnetic field depends on direction of flow of current also. So you can apply right hand rule here. You can put your fingers in the direction of current. You can place your palm in the direction of the point where you want to find out the magnetic field, and the direction of the thumb will give you the direction of the magnetic field. I'm again repeating it. To find out magnetic field at any particular point, to find out, yes, yes, Param, you are absolutely right. So the direction of the magnetic field, I'm again repeating, you can find it out by right hand's rule. And right hand rules tells me that put your fingers in the direction of the current, the palm point where you want to find out the direction of the magnetic field, and the thumb direction will give you the direction of the magnetic field. This is the right hand rule. So that's how you can find out. Now magnetic field due to a current, so remember this. So in your book, there is only one formula given over here. So remember this formula, and this formula is if a very long current carrying infinitely long, so they will never write infinitely long. They'll only write long current carrying conductor. So if a long current carrying conductor is there, the magnetic field due to a long current carrying conductor B would be equal to mu naught by 2 pi I divided by D. What is D? Distance of the point where you want to find out the magnetic field. So suppose this is the point. So this is the perpendicular distance from this current carrying conductor. So distance of the point, perpendicular distance of the point from the current carrying conductor would be known as would be known as the magnitude of the magnetic field. Now try to understand. I'm giving you a question. The question is, so the question is, so there are two current carrying conductors. One is like this and this is I1, and one is like this is I2, and distance between them is 15 centimeters. And here is a point which is 5 centimeter from here. At this particular point P, you have to find out resultant magnetic field. Okay, what is the answer, guys? I1, I2, I have already given to you. No, I have not given I1, I2. Okay, I'm sorry. I'll give you I1, I2. So just replace it in the value. I1 is equal to 15 amperes and I2 is equal to 10 amperes. Guys, after this question, I'll have to wrap up the session. Um, so rest of the things, rest of the magnetism portion, perhaps before your examination, just remind me. I'll take that class and finish it off. So whenever is your examination, 1 or 2 days before it, I shall be taking a class and I'll finish it off. So don't worry about it. Rushil, just remind me, Rushil and Param. So now look at here, guys. The answer would be it is B1 plus B2. So look at here. When I put my fingers in this direction and palm in this direction, so force would be in this direction. And when I put my fingers in this direction and palm again in this direction, again the force would be in this direction, or magnetic field would be in the same direction. So magnetic total resultant magnetic field B would be equal to B1 plus B2, and B1 is equal to mu naught by 2 pi. I is 15 divided by 5 centimeters. So I will convert it into 5 into 10 to the power minus 2. And this would be mu naught by 2 pi. I is 10 divided by, this will be 10 centimeters. So 10 into 10 to the power minus 2. So mu naught by 2 pi is 2 into 10 to the power minus 7 into 3 into 10 to the power 2 plus this will be 2 into 10 to the power minus 7 into this 10, 10 will go, this will become 10 to the power minus 2 only. So this is 6 into 10 to the power minus 5 plus 2 into 10 to the power minus 5. So this comes out to be nothing but 8 into 10 to the power minus 5. So sorry, or 80 into 10 to the power minus 6. So this becomes 80 micro Tesla. So that's your answer. So your answer would be 80 micro Tesla. How many of you got it? How many of you got the answer? Okay, so guys, I'm wrapping up the session. The rest of the topics I will revise it in the next class. So the topics remaining today are AC and DC generators and electromagnetic induction. So 1 hour class, 1.5 hours of class would be sufficient enough for that. So I shall take that later. So what I'll do is that I'll cover that. I'll cover those topics in different class, or so just remind me before that. Okay. So thank you so much, guys. Okay, no issues. Thank you so much, all of you. I shall be wrapping up the session now.